Ever catch yourself thinking about a do-over? You know, that one moment
Hmm.
back then that you just love to rewind and, I don't know, handle differently.
Oh, absolutely. Like forgetting your homework or maybe saying something awkward on a first date happens to everyone.
It's this like universal human thing wanting to tweak the past. But what if it wasn't just, a personal slip up? What if you could go way back to a really crucial moment?
Ah, now you're getting into it. That leads us straight to a really famous thought experiment, one that's, well, been puzzling scientists and philosophers for
The
ages.
grandfather
The
paradox.
grandfather paradox, indeed. It's a
Uh,
real classic. The idea is, okay, imagine you build a time machine, right? And you go back and somehow you stop your own grandfather from ever meeting your grandmother.
okay.
Well, if that happens, your parent wouldn't be born,
Right, logically.
and neither would you.
Right.
So then who jumped in the time machine in the first place?
Whoa, yeah, that's a knot. A real tangle of cause and effect. It feels like it just breaks logic.
It does seem to. And it's not just fun sci-fi chatter, you know?
Yeah.
It digs really deep into how we think causality works, what existence even means. It reminds me a bit of how obsessed humans were with flying for centuries. Seemed impossible, but the idea just gripped us. Tinkering with time is kind of similar.
That's a great comparison. So for this deep dive, we're going to really tackle this paradox. We're digging into it. We'll look at some fascinating ideas from physics, you know, Einstein's curved space-time and the really, really weird world of quantum mechanics. We want to see if science offers any, I guess, escape routes or ways the universe might handle such a situation.
Sounds like a plan. And hopefully we can break it down so you don't need a PhD to follow along, right?
That's the goal, making the mind-bending stuff accessible.
Okay, so where should we start? Maybe with a classical physics perspective.
Yeah, let's do that. Einstein's general relativity seems like the place.
Right. So one of the biggest ideas from Einstein is that space and time aren't these separate static backgrounds. They're woven together.
Into space-time, like a fabric.
Exactly. A single fabric, space-time. And here's the kicker. Einstein showed that this fabric isn't flat. It gets bent, warped, stretched by mass and gravity.
Okay, I can picture that. Like putting a bowling ball on a trampoline, it creates a dip, a curve. Planets and stars do that to space-time.
Precisely. And that bending affects how things move, including light and potentially time itself.
So how does this warping lead to time travel possibilities?
Well, buried in the mathematics of general relativity, some physicists and mathematicians folks like Willem Jacob van Stockham and later Kurt Gödel, who actually knew Einstein.
Oh, interesting connection.
Yeah, they found that under certain very extreme conditions, the theory allows for something called closed time-like curves. CTCs for short.
Closed time-like curves. Okay, what does that mean in like simpler terms?
Imagine drawing a path on that space-time fabric. A CTC is a path that loops back on itself, not just in space, but in time.
Oh.
So theoretically, if you could follow such a path, you could end up back at a point in time you've already experienced.
A literal time loop. Like you start driving and somehow the road brings you back to your starting point, but maybe yesterday.
Something like that, yeah. Though the conditions needed are probably, incredibly exotic, like near rotating black holes or cosmic strings, if those exist.
Okay, but if these loops are even theoretically possible, what happens to free will? If I go back intending to, say, stop my grandfather.
That's the million-dollar question, isn't it? If you're on a CTC, the very structure of that loop might constrain your actions. The idea, sort of, is that for the loop to exist consistently, anything you do inside that loop has to ultimately lead back to the conditions that created the loop in the first place.
Meaning?
Meaning, maybe you can't actually stop your grandfather. You go back, but perhaps your gun jams.
Yeah.
Or get delayed. Or maybe someone intervenes.
So the outcome is kind of predetermined by the loop itself to avoid a paradox.
That's one interpretation, yeah. The consistency of the timeline demands that the past unfolds in such a way that you do eventually exist to go back in time. Your free will inside the loop might be, well, limited. Or maybe even an illusion.
It's like the universe has a safety mechanism. Nope, can't break causality here.
That's exactly the thinking behind concepts like Stephen Hawking's chronology protection conjecture.
Hawking, right. I've heard of that.
Yeah, and also Igor Novikov's self-consistency principle. They basically propose that the laws of physics themselves might actively prevent paradox-causing situations, either by forbidding these CTCs from forming under realistic conditions, or, if they do form, by ensuring that only self-consistent events can happen within them.
So no matter what you try to do, the universe ensures the outcome doesn't lead to a contradiction.
That's the classical physics attempt at a resolution, essentially. Avoid the paradox altogether through physical constraints.
Okay, that makes a certain kind of sense. Consistency rules.
Yeah.
But classical physics isn't the whole story, is it?
Not by a long shot. Things get even stranger when we bring quantum mechanics into the picture.
Right. Quantum mechanics. This is where we get particles being in two places at once and cats being alive and dead.
Huh. Yes, the infamous Schrodinger's cat. That thought experiment highlights a core quantum idea: superposition. Basically, before you measure a quantum system, it can exist in a combination of multiple possible states at the same time.
So not just state A or state B, but A and B simultaneously.
Exactly. It's only when you interact with it, when you make a measurement or observation, that it collapses into one definite state.
That's still so counterintuitive. How does superposition help with the grandfather paradox? Is my grandfather like both alive and not alive in the past until I show up?
Well, applying quantum ideas here is speculative, of course, but that's kind of the direction some thinking goes. Before your potential intervention, the state of your grandfather regarding his future existence leading to you could be seen as being in a sort of superposition. Your arrival and actions are the observation that resolves the uncertainty from your perspective.
Okay. But if I do resolve it in a way where he doesn't meet my grandmother, doesn't that still create the paradox? I still wouldn't exist to have made the observation.
But this is where another quantum interpretation comes in handy, perhaps the most famous one for dealing with these kinds of problems.
Yeah.
The many worlds interpretation.
Many worlds. Sounds like serious sci-fi.
It does, but it's a serious interpretation of quantum mechanics proposed by Hugh Everett III. The basic idea is that every time a quantum measurement or event happens where there are multiple possible outcomes, the universe, well, it splits
Splits, like actually branches off.
into multiple parallel universes or timelines. Each possible outcome happens, but in its own separate reality.
Wow. Okay. So take the grandfather scenario.
Right. You go back, you try to stop your grandfather. According to many worlds, at the point of your intervention, reality splits. In one branch, one universe, perhaps you succeed. Your grandfather doesn't meet your grandmother. In that specific timeline, you were never born.
Okay, so I create a timeline where I don't exist. But what about the original me, the one who traveled back?
That's the key. The original timeline, the one you came from, continues on its own path. In that reality, your grandfather did meet your grandmother, you were born, and you did travel back in time. That reality remains unchanged by the new branch you created.
So I don't erase myself from existence entirely. I just create a new reality where I don't exist, but the old one is still there.
Exactly. Think of it like drawing a line on paper representing time. At the point of your intervention, the pen splits, and now you have two lines diverging from that point. Both lines exist.
One line where I succeeded and vanished from that timeline, and another line, my original one, where everything proceeded as I remembered it.
Precisely. The paradox dissolves because both outcomes, grandfather lives, grandfather doesn't live, due to your actions, are realized just in different universes. There's no logical contradiction within any single timeline.
The universe just says, sure, have it your way. Over there. Everything's fine here.
That's a good way to put it. The multiverse accommodates all possibilities. So even if you cease to exist in one branch, the overall structure of reality, the multiverse, remains consistent.
That is profoundly strange, but it does seem to resolve the paradox, in a way.
It's one potential resolution offered by interpreting quantum mechanics in this particular way. It's not the only interpretation, but it's a compelling one for thought experiments like this.
So we have classical physics saying no paradox is allowed, consistency is king, possibly through physical constraints, and quantum physics, or at least the many worlds view, saying paradox, no problem, just split reality.
That sums up the two main approaches pretty well, yeah. Different ways the universe might handle causality loops.
Now, we should probably emphasize actual time machines. Still fiction, right?
Oh, absolutely. While we've seen evidence supporting Einstein's ideas like time dilation, time actually running slower for fast-moving objects or in strong gravity.
Right. GPS satellites have to account for that, don't they?
They do. It's real. But building a machine that can navigate CTCs or jump between quantum timelines, that's purely theoretical at this point, way beyond our current capabilities and maybe fundamentally impossible.
Still, exploring these ideas, these paradoxes, it feels valuable, doesn't it? Even if we can't build the machine.
Incredibly valuable. Thought experiments like the grandfather paradox are crucial. They push the boundaries of our theories. They force us to ask deep questions about time, reality, causality. Einstein himself relied heavily on thought experiments.
It forces us to really think about how the universe might work at its deepest levels.
Exactly. Grappling with these seemingly impossible scenarios sharpens our understanding of the possible and reveals the profound implications of our best scientific theories.
Okay, so wrapping this up, we looked at the grandfather paradox. Classical physics suggests maybe time loops are self-correcting or impossible to create paradoxes in.
Through things like Hawking's chronology protection or Novikov's self-consistency.
Right. And then the quantum view, especially many worlds, offers this idea of branching realities where every outcome happens, avoiding contradiction by splitting the universe.
Yep. Two very different, fascinating perspectives on how causality might be preserved.
And the big takeaway seems to be that even though hopping in a DeLorean isn't happening tomorrow,
Probably not.
thinking about these paradoxes actually teaches us a huge amount about space, time, and, well, the very fabric of reality.
Precisely. The journey of exploring the question is as important, maybe more important, than finding a definitive answer about building a time machine. It deepens our fundamental understanding.
It really makes you wonder if the quantum world allows for these seemingly contradictory states, like superposition or multiple worlds. Could our everyday reality be governed by stranger principles than we usually assume?
That's a fantastic thought to leave people with. What other counterintuitive rules might be operating beneath the surface of our perceived reality?
Makes you think. Well, if you enjoyed this dive into time travel, paradoxes, and the weirdness of physics, definitely follow us for more deep dives into science and big ideas.